Hello, students. Today we're going to work on the third method for solving systems of equations. And algebraically, this one's called elimination. And you might also think of it as stacking them up. So we're going to stack up the two equations and try to eliminate one variable when we add the two equations together. So our first problem, we have x plus y equals 4 and negative x plus y equals 8. So one of the things that we could do right at the very beginning is to look to see what happens if we would just combine these two equations. Adding the two, we would have the x and the negative x actually canceling, and that's exactly what we want to have happen. On elimination, one variable eliminates. Now we're going to be adding 1y and 1y. And so that makes 2y, which equals 12. And then dividing by 2, we would get y equals 6. So it doesn't matter which variable you do find first. This time we found the y first. Now we have to go back and find the x. You're going to do what we did in substitution method. I would use the top equation if you want consistency. It really doesn't matter which one. So we found the we found the y, and we have to substitute in our answer, which was 6, in order to solve for the x. So x plus 6 equals 4. We will subtract 6 from both sides of the equal sign and discover that x equals, and then 4 minus 6 is negative 2. And then we want to write your final answer as an ordered pair. So the ordered pair solution for x is negative 2, and for y is a 6. And remember that your solution has to make both equations true. So very quickly, negative 2 plus 6 would equal 4. And then the negative of negative 2, that would be positive 2, plus 6 would equal 8. So it makes both equations true. All right, now, not every set of equations can just be added at the very beginning and have a variable eliminate. For example, and don't write this down, if we were to just add this equation, 1x plus 1x would be 2x, 2y minus y would be plus y, and then we'd have equals 9. And so that doesn't work. And by the way, I remember I had made a typo on this problem. So before we even start doing anything else, the 1 needs to be changed to a negative 1. So everybody make that change at this time. The 1 in the original problem should be a negative 1. Make sure you make that change. All right, so we can't get a variable to eliminate by just adding the two equations together. So instead, we're going to have to multiply one, sometimes both equations by something. So if I would recopy my top equation, and remember that the 1 is supposed to be a negative number, so it equals negative 1. And if I take my bottom equation, if I'd like to eliminate the y, then I could multiply every term on both sides of the equal sign by a 2, and I'll show you what happens with that. You get 2x minus 2y equals 16. And when we add those two equations together, 1x plus 2x would equal 3x. The y's, you have a 2y and a negative 2y, they eliminate, and then equals, and then negative 1 plus 16 would make 15. We can divide both sides by 3 and get x equals 5. So your first solution is the x equals 5. And then you can substitute into either equation. So I'll use that top one. Remember, it had a mistake in it. So x plus 2y equals -1. That's what it was supposed to be originally. I'm going to put the 5 in for the x. So 5 in for the x. Let me change colors on that. 5 plus, and then 2y equals -1. So we'll continue to solve by subtracting the 5 from both sides of the equal sign. So -5 and -5. So the 5s will cancel. That'll give us 2y equals, and then -1 and -5 make -6. And divide both sides by 2 to get y equals -3. Remember to write your final answer as an ordered pair, the x coming first and the y coming second. So 5 and -3. And so we were able to eliminate a variable on problem 2 just by multiplying one equation. So problem number 1, we didn't have to do anything to either equation. We just started off adding. Problem number 2, we had to take one equation times something so that we could get a variable to eliminate. On problem number 3, if I add them right now, nothing will eliminate. And I don't have anything in common between the 2 and the 5, or between the 3 and the -2, where I could just get away with multiplying by or on just one equation. So instead, I'm going to multiply both equations, and I'm going to focus in on the y because the y already has opposite signs. So since I have a 3 and a -2, I'm going to try to make each one of them be a 6, one of them a +6, and the other a -6. So I'm going to multiply the top equation by 2, which will let me then get a +6y. So multiplying by 2, I'm going to write my answer over here. I'll have 4x plus 6y equals 24. Now, for my second equation, I've created a +6y. For my second equation, I need to create a -6y, and a 3 will make that happen. So if I multiply everything by 3, I'll have 15x and then -6y. So notice, same numbers, opposite sign, equals, and then 3 times 11, 33. So now when we add our two equations together, 4x plus 15x would add together to make 19x. My y's have the same number, opposite sign, they cancel. And then my constants, 24 plus 33 makes 57. We can divide both sides by 19. And when you divide 57 by 19, you get x equals 3. So we have found the x. We'll go back into the original, and I'm going to do the top equation. So let me write that down. 2x plus 3y equals 12. I'm going to substitute in place of the x. I'll use my answer. My x was a 3. And then plus 3y equals 12. So I substituted. 2 times 3 makes 6. So 6 plus 3y equals 12. I can subtract 6 from both sides of the equal sign, making 3y equals 6. Dividing by 3 on both sides, I get y equals a 2. And then my solution is clear down at the bottom of your paper there. The solution blank is. So I'll just write it here. Your solution would be the ordered pair 3, 2. That would make both equations true. So 3, 2. And I'm going to do a new video to work on equations 4 and 5.